Welcome to the severe thunderstorm forecasting example for hurricanes or tropical cyclones. My name is Joseph Patton and I'll be your guide today. Don't forget to check out weatheracademy.org for more on learning how to forecast the weather and meteorology. Quickly recall our forecast cone method, which starts with more broad or more general spatial and temporal or time scales, and then gets more specific as more details are understood closer to the event. This gives the forecast cone its shape, and it will be our guide for understanding how to forecast severe thunderstorms. You may recall from our other severe thunderstorm lessons the ingredients-based forecasting method, but hurricanes or tropical cyclones don't follow the normal path for shear, lift, instability, and moisture that typical mid-latitude severe thunderstorms do. Hurricanes are unlike other forms of severe weather in that these traditional forecasting methods are not applicable. Hurricanes tend to thrive in environments with low shear and low instability, but with very high moisture. So typically for hurricanes, we're looking for environments with low shear, not a lot of surface fronts, so no discernible lift. We want a nice uniform environment in which the hurricane can feed on the low cape or low instability and the large amounts of moisture in the atmosphere. That's how the hurricane gets its energy to continue propagating and continue thriving. Some other considerations would be that jet streams or jet streaks are damaging because of the large wind shear values to hurricanes, and also land, which induces friction near the surface, would tend to disrupt the flow around hurricanes and would be detrimental to them. However, this friction from land can play an important role in the formation of tornadoes, and when tornadoes do tend to form in tropical cyclones or hurricanes, they almost always form in the right front quadrant, typically within the outer rain bands. So if we have a tropical cyclone making landfall, the right front part of the storm is where we're going to be looking for tornadoes to possibly form. We're going to jump straight into the most important variable when forecasting tropical cyclones, and that's moisture. In this example from August of 2020, we're looking at Hurricane Isaias, which is along the eastern coast of the United States. It's occurring, we can see it's occurring on this 925 millibar analysis. These black contours indicate lowering heights, or basically our low pressure system. And that system is going to be moving with our steering flow, which we'll look at in a moment. But for now, just recognize that we've got all of these green contours in this area indicating very high moisture. So we've got a favorable environment for this tropical cyclone. And we also generally have cyclonic or counterclockwise flow around the storm. And that counterclockwise flow is going to be a favorable environment for developing the storm and potentially leading to tropical cyclone tornadoes. Next, let's look at our shear and our upper level flow. We can see that in the general vicinity of our storm, which remember is off the coast of the southeast United States, generally in this area, the shear values are relatively low. We have just a 10 knot shear near Jacksonville and just about 30 knots shear near the coast of North Carolina. And these relatively weak upper level winds, which essentially indicate our wind shear, are going to be fairly favorable for our tropical cyclone, which in this case is Hurricane Isaias. Our flow is generally from the south-southwest, so that is the direction that our tropical cyclone is going to take, which basically means it's going to ride up the coast of the eastern United States. This is an observed sounding from August 3rd, 2020 along the coast of South Carolina near Charleston, South Carolina. And this is a very typical sounding for a tropical cyclone environment. See that we've got our tropical environment with very high dew points, where the green line representing the dew point temperature is very close to our red line, or our environmental temperature. That means we have fairly high dew points and a fairly moist atmosphere all throughout the pretty much most of the tropopause, most of the troposphere. We also have generally weak wind shear values, maybe 10 or 20 knots up until 500 millibars, and even above then, we only have about 30 or 40 knots of shear or wind speed, and that means that there's not going to be much shear to tear apart our tropical cyclone or our hurricane. And we can see that in the hodograph too, as the hodograph pretty much kind of all sits around the same area instead of going off in one direction. So we know that there's not a ton of deep layer shear, but there is a lot of deep layer moisture, as we can tell from the dew point temperature, which the green line, and we can also tell from the precipitable water, or PW here, is over 2 inches, which is very high. That means that there's over 2 inches of liquid water which can precipitate out of this environment and potentially lead to flash flooding, which is one of the main concerns of a tropical cyclone. In addition, our lapse rates are very weak. In the lower left-hand corner, we can see that lapse rates are generally around 5 degrees Celsius per kilometer, or even less in the low levels. And that relates to how quickly our temperature is decreasing with height. So that leads to very little instability. We can see there's some instability between our air parcel, the dashed dark red line, and our environmental temperature, the solid red line, which is leading to a few hundred joules per kilogram of CAPE, maybe about 365 in this sounding, but not very much, kind of a long and skinny CAPE like we talked about earlier. So there's not a lot of instability, but there's a lot of moisture and not a lot of wind shear. And this is a classic tropical cyclone sounding. So if we're looking at our right front quadrant for our storm, we may be concerned about tropical cyclone tornadoes. Putting it all together, here is the Storm Prediction Center, or SPC, severe weather risk from this day. Notice how we have a slight risk of severe thunderstorms along much of the central eastern coast of the United States, stretching from South Carolina all the way up into Maryland. And as this storm tracked further towards the northeast, they extended the slight to include areas up into New England as well. So this slight risk represents that, yes, we think that there could be some scattered reports of tornadoes, but we're unsure how widespread they're going to be or how strong they're going to be. Here are the preliminary local storm reports representing severe weather that was reported on this day. This is more of a 2-day event from the 3rd to the 4th. So we're just looking at the event reports around the southeast and mid-Atlantic coast now. On the 4th, there were more reports of tornadoes up into New England. But for now, notice that all of our red tornado reports are congregated right along the coast. As our storm was moving upward, these would all be on the right side of the storm and typically in the front right quadrant. So there were dozens of weak, brief tornadoes that occurred in the right front quadrant of the storm. And unfortunately, at least 2 fatalities and 22 injuries were directly related to the tornadoes within this tropical cyclone, Hurricane Isaias. And there were even more the following day. So this is a good example of how to understand environments which lead to tropical cyclone tornadoes and how to prepare for them. And if you have any more questions about weather or meteorology, send them to us over at weatheracademy.org, and happy learning.